So I welcome you all for the next digital communication lecture series. In this lecture series, so far we have completed the block codes. Okay, so now we are going to deal with the Hamming code. Okay, so Hamming code is given by R.W. Hamming. Okay, R.W. Hamming is a scientist who have discovered this Hamming code. Okay, so for what we are going for Hamming code? Hamming code is mainly used in order to detect and in the correct the error. Okay, so this is the main advantage of going for the Hamming code. Okay, so in this what we will do is we will be sending the data along with the parity bits. Okay, so by doing so we can easily detect and correct the errors. Okay, and how we can represent the Hamming codes? The Hamming codes is represented as n comma k. In this, n is nothing but the total bit and k is nothing but the message bit. Okay, so and p is nothing but the parity bit. Okay, as always in this unit, wherever you are seeing the value as p, you have to take it as parity bits. Okay, so p is equal to n minus k. So that is the general formula that you know. Okay, so and now what I am going to do is I am going to show you an algorithm. Okay, so we can say it as an algorithm to how to find the values by means of using the Hamming code. In this also we are going to find the values of the parity bits. Okay, so that is what the main aim of this Hamming code. Okay, so let's get into the lesson and let's check how to calculate the values of parity bits. Okay, so first of all we have to identify the parity bit. Okay, so if we are going to identify the parity bit, means it has to satisfy one given condition. So the given condition is 2 power p is equal to p plus k plus 1. Okay, is greater than or equal to p plus k plus 1. Okay, so 2 power p equal to p plus k plus 1. Okay, so for I'm assuming that this problem has 4 message bits, that is k is equal to 4 message bits. Okay, so 4 bits. So this function will become as, this equation will become as 2 power p is greater than or equal to p plus k plus 1. It is the given equation. Okay, so this equation will be replaced and by the value of k as 2 power p is greater than or equal to p plus 4 plus 1. Okay, so if I add this will become as p plus 5. Okay, so this value is equal to 2 power p plus 5, and I am going to substitute the value for p from 1 to infinity and I am going to find the values of p. Okay, so if I do so what will be the value of p? It has to satisfy this condition. If you substitute if you substitute p equal to 1, it has to satisfy the given condition. Okay, so that is what I am going to do over here. So let us consider for p equal to 1. If I substitute p equal to 1 in this given equation, what will happen? 2 power 1 is greater than or equal to 1 plus 5. Okay, so what is 2 power 1? It is 2, so it is 6. So this condition is not satisfied. Okay, so now I am going to iterate the value of p. So value of p I am increasing it to 2. So 2 power 2 is greater than or equal to 2 plus 5. 2 power 2 is equal to 4 and 2 plus 5 is equal to 7. So this condition is also not satisfied. Then I am going to substitute for p equal to 3. Okay, so if I substitute the p value as 3, what I will get? So 2 power 3 is greater than or equal to 3 plus 5. Here we know already, that is 2 power 3 equal to 8 and it is greater than or equal to 8. So this condition is satisfied. Then what is the value of p? The value of p is equal to 3. Okay, and k equal to 4 we already know. Okay, so now I want the n value. N value is nothing but k plus p. Okay, so what is n value? It is 4 plus 3 and n value equal to 7. Okay, so we have found that the p value equal to 3, k value equal to 4 and n value equal to 7. Okay, so now we are going to find the position of the code words. Okay, so first before finding the position of the code word, there we have 7 bits. Okay, so we have found that we have 7 bits, 1 2 3 4 5 6 and 7. Okay, I'm mentioning the position of the bits 1 2 3 4 5 6 and 7. Okay, so out of 7 we have 3 parity bits. Okay, we have found that we have 3 parity bits. Now I am going to identify the position of the parity bits. Okay, out of this 7 positions, where the parity bits are going to occupy its position, that is what I am going to find. Okay, ஸோ இந்த கொடுத்துருக்கிற இந்த 7 பொசிஷனில் எந்த பொசிஷனில் பேரிட்டி பிட்ஸ் எனக்கு 3 பேரிட்டி பிட் கிடச்சிருக்கு. ஓகேவா, ஸோ 3 பேரிட்டி பிட் இருக்குது. அந்த 3 பேரிட்டி பிட் எங்கெங்கே வரணும் அப்படின்னு நான் ஐடென்டிஃபை பண்ண போகிறேன். ஓகேவா? ஸோ அதை ஐடென்டிஃபை பண்ணுறதுக்கு என்ன பண்ணணும் அப்படின்னா ஃபஸ்ட்டு p ஈக்குவல் டு எண்ணுக்கு p ஈக்குவல் டு 2 பவர் n அதான் வந்து ஜென்ரல் ஃபார்முலா. ஸோ இந்த ஜென்ரல் ஃபார்முலாவில் p ஈக்குவல் டு 3 அப்படிங்கிறதுனால என்னோட வேல்யூ 0 1 2 நான் சப்ஸ்டியூட் பண்ண போகிறேன். ஓகேவா? ஸோ 0 1 2 சப்ஸ்டியூட் பண்ணுறப்ப எனக்கு என்ன வேல்யூ கிடைக்குதுங்கிறத நம்ம பார்க்க போகிறோம். ஓகே, ஸோ ஃபஸ்ட்டு 0 சப்ஸ்டியூட் பண்ணுறோம். 2 பவர் 0 இட் இஸ் 1. ஓகேவா? ஸோ அப்போ p1. ஓகே, ஸோ நெக்ஸ்ட்டு 2 பவர் 1. ஸோ 2 பவர் 1 is 2. ஸோ இங்கே வந்து 2 வந்துடும். ஓகேவா? ஸோ நெக்ஸ்ட்டு p is equal to 2 பவர் 2 சப்ஸ்டியூட் பண்ணுறோம். ஸோ 2 பவர் 2 is 4. ஸோ I'll be getting p4. ஓகேவா? ஸோ ஃபஸ்ட்டு இந்த இதில் வந்து பார்த்தீங்கன்னா இங்கே வந்து பார்த்தீங்கன்னா p1 ஆக்குப்பை ஆகும். அதே மாதிரி p2 will occupy in the second position and p4 will occupy in the fourth position. Okay, so this is how you have to calculate the values of you have to calculate the position of p1 p2 and p4. Okay, so rest of the things you can fill it up. ஏன்னா இது வந்து பார்த்தீங்கன்னா நம்ம மெசேஜ் பிட் வந்து we have 4. Okay, so that is d3 d5 d6 and d7. So this is how we have to fill the values of the bits. Okay, so next, what is the next step? We have to find the values of p1 p2 and p4. So for that what we have to do, let's check it out. Okay, so for that what we have to do is, so first I am going to consider the bits values. Okay, so what is the bit value that we have already found, right? So what is the value? So that is p1 p2 and here it is d3 and here it is p4, here it is d5 and here it is d6 and here it is d7. Okay, so now I am going to find the value of p1. Okay, so how we can find the value of p1? We have to, there is a rule, check one bit and skip one bit. Okay, so we have to check one bit and we have to skip one bit. Let's check how to calculate that. Okay, so let us assume this is the position of p1. Okay, so we have to check this bit and we have to skip this bit. Okay, we have to skip this bit and again we are going to check this bit and we are going to skip a bit. Okay, so and we are going to check this bit and we are going to skip this bit. Okay, so what will be the value of p1? So p1 will be equal to, it is d3 XOR of d5 XOR of d7. Okay, so let me repeat the step again. Okay, so I am considering p1 as the initial one. I am going to find the value of p1. So for p1 I am going to check this bit, I am going to skip this bit. Okay, so the value will be d3. Okay, and I am going to check the d3 value and I am going to skip this bit, so the value will be d5. And I am going to check the value of d5 and I am going to skip the value of d6, so the value will be d7. Okay, so this is how you have to find the value of p1. Okay, so next I am going to find the value of p2. So for that I am redrawing the diagram. So it is d7 d6 d5 p4 d3 p2 and p1. So in this case I am going to find the value of p2. Okay, so what is the value of p2? How to find the value of p2? So for p1 what you did, you have checked one bit and you have skipped one bit. Okay, so for p2 what you have to do is, you have to check 2 bits and skip 2 bits. Okay, so this is the condition. So if I write the value of p2, what will be the value of p2? So you have to consider, you have to check this bit. Okay, so we have to check 2 bits and we have to skip 2 bits. Okay, so if we skip 2 bits means what will be the value? The value will be equal to d3 d6 d7. Why I am including d3 means this d3 is associated with p2, so that is why we have to consider this d3 also. So the value will be equal to d3 XOR of d6 XOR of d7. So this is the value of p2 and this is the value of p1. Okay, so this is how we have to find the value of p2. Okay, you should not go beyond this. Why? Because we have only 7 bits. If we have 10 bits or 12 bits, we can proceed in this way. Okay, since we have only 7 bits, we have to terminate up to this. Okay, so now what we are going to do next, we are going to find the value of p3. So in order to find the value of p3, I am redrawing this. So this is d7 d6 d5 p4 d3 p2 and p1. Okay, so listen carefully. So in this case there we have for p4. Okay, so for p4 what we have to do, we have to check 4 bits and we have to skip 4 bits. Okay, so once we if we do so, the what will be the value? The P4 is here, so for P4 we have to check 4 bits. So 1 2 3 4. After this there is no bits to skip. Okay, so we have to write the values as D5 D6 and D7. So the P4 value will be equal to D5 D6 D7. Why? Because this D5 D6 D7 are associated with P4. So this is how we have to find the values of P1, P2 and P4. Okay, so thank you so much for your valuable watching. In the next video we shall continue with the numerical. Thank you one and all.